Hello everybody, in this video I am continuing the series where we are building a real AI-powered system using Microsoft Agent Framework in ASP.NET Core. So far our agents actually work, but there is one big problem: they forget everything after a start. So in this video we are going to fix that by saving conversation in a database. Alright, let's start with the packages we need. We will use Entity Framework and PostgreSQL. So let's go to Nugget. Let's add Entity Framework Core. Let's also add PostgreSQL. And Designer for migrations. Let's also upgrade our packages for Microsoft Agent Framework. They released a new version. Next, let's do a bit of refactoring in our entities. Nothing too crazy, just a few small improvements. First of all, let's add a created@add property and add created@add here with datetime UTC now. Next, let's switch conversation message from record to class. Like this. Also, we need parameterless constructors for both conversation message and conversation because Entity Framework requires it, and we want also to use constructor with parameters. Like this. And the same constructor without parameters here. So conversation message will have reference to conversation, agent name, role, contents, and created@add. We also want to make sure that messages list can be modified from outside of the conversation aggregate. For that, let's change it to messages field, and I read only list messages property. This messages property will take messages field, order by it by created@add, and convert it to read-only list. And switch here to field. And small tweak in addMessage method. We want to create conversation message object here, not outside of the conversation, because conversation is our aggregate root and conversation message is just a child entity. Now let's fix a book order workflow runner because it's a little bit broken. First of all, we need to remove this here and add datetime UTC now here, and message created@add. It's a datetime offset, so we need value and UTC datetime, and also without new object. Now let's create our DB context. For that, let's create a new folder, infrastructure. Let's call it book agent DB context. Nothing fancy here, just we register two DB sets for conversation and for conversation messages. We also need on model creating overridden method. To keep this clean, we will move all entities configuration into separate classes so that DB context doesn't become a mess. If you want more details on that, check one of my previous videos. Now let's create an entities configurations folder and configuration for conversation. This one will be simple. We just need ID which is generated manually, not auto-generated, and relation to messages. So one conversation has a lot of messages and each message has only one conversation. And configuration for conversation message. It will be a bit complexer. So we also want to manually generate ID. Agent will be varchar with 50, role will be varchar with 32, contents will be JSONB, and also relation to conversation here. Now we need to add converters that we could convert role and contents to database values and back to C# data structures. Let's create a new folder here, converters, and let's start with chat role converter. So C# value is chat role, database value will be converted to string. When we want to convert it to database value, we just used value from chat role. So value here is a string because chat role is a structure which have this property value. And when we want to convert it from database string to chat role, we can just use new chat role from this string. Now let's create a content converter. C# data structure is list from AI content and database value is a JSON string. When we want to convert it to database value, we just use a JSON serializer and convert this content. When we convert from JSON string, we also use a JSON serializer and convert this string back to list of AI content. But main point here is an option. We could use iJSON utilities default options. It's predefined for us by Microsoft Agent Framework JSON serializer, which could work with serialization of this AI content. And we also need to allow out of order metadata properties to be true. This makes the serialization more robust when working with polymorphic JSON, especially when type field is not in the first place. Alright, now let's implement the database version of iConversation store and do small refactoring there as well. So here is a conversation store. Let's make it to return task of conversation. For that, let's also change an implementation here and use task from result. And the same here. Let's also add one more method here. Because database conversation store, we will need to save changes after new messages come in. We also have to implement it here, but we can just use task completed task because we don't need any implementation for in-memory conversation store. And let's implement database conversation store. We need to inject book agent DB context here and fetch from DB context conversation DB set to use it for querying. In this get or create async method, we are fetching conversation by ID and include all messages which are connected to this conversation. If conversation is not null, we return conversation. Otherwise, we create a new conversation, ask Entity Framework to track it, and save it to the database and return it afterwards. In the save changes async method, we just save everything which is tracked in Entity Framework to database. Now let's modify our book order workflow runner a bit. Here we need await now, and here we need save changes async, because when we add new messages, we need to store them into database. Next step is a database. I'm going to run one in Docker through Docker Compose, but honestly, you could use anything like local database, Azure, AWS, doesn't matter. So let's create Docker Compose YAML file with such content. I will not go deep into Docker Compose here. I already covered the topic in another video, you could check it. Now let's up our Docker Compose. So database is running now. And next thing, let's register everything in dependency injection container. First of all, it's our database context. Don't forget about DB connection string in your app settings JSON file or any other secret storage. Like this. And let's also switch implementation from in-memory to database. And now we have to use scoped instead of singleton. And now comes an important fix in our book order workflow runner. First, we actually have a small bug here. This executor ID here and here is not an agent name, it's a node name, but we want it to be an agent name. So let's first fix this one. We don't need event here anymore. And we could fetch agent from message. It's in outer name property. And here we cannot use start executor ID. Let's do something different. Let's go to our agent, book recommendation agent, and create new const name with the name of this agent and use it here and here. And we also need to set it to message like this after name message agent. And we also created new property created that, so let's also push it. Second important thing that we want to rely on created at property for messages, like we describe it here. So we sort all messages by created at. But we can't rely on this created at from LLM. In this for each, order of messages are correct, but created at property in each message is wrong. Yeah, for example, tool result before the tool was even called or something else. So we need to use our daytimes here. So let's do it. Let's create a new variable now and use it here. But we actually want that several messages not be in same daytime. So let's apply some small hack here. We add 1 millisecond after each iteration of this for each. Now let's create a migration. We also forget to apply converters. we need to add converter here, as conversion, chat role converter, and here as conversion, content converter. Now let's run migration one more time. It's successfully created. Here in migration folder, we have new migration. Let's check it. Migration builder, create migration, name, ID and created add. Everything is correct. Messages with ID, conversation ID, agent, role, content, which is JSONB, created add, and foreign key to conversation. So everything looks correct. So now we could apply this migration. It's applied. Let's connect to database in Rider. You could connect to your database in any other database client. We use Postgres, port is custom one, user password database, test connection, connect to database. Now we can see 3 tables here: messages, conversations, and migrations history. And basically that's it. Let's run everything and check what we have in the database afterwards. Let's go to Swagger and use our general flow. Here is new conversation ID. And let's start chatting. Hi. What genre? Science fiction. Writer. Something 2020 plus. It recommends 2 books to us. We want to order first one. Great choice. Would you like to place the order for you? Yes. Could you provide delivery address and payment method? Execute. Your order has been successfully placed. Your order ID is this one. So it's working. Now let's check the database. Let's open messages and let's close everything else. Let's also sort it by created at. Okay. Let's expand it a bit. So as we can see, the workflow started from book recommendation agent with our message from user role with hi and type is text. Then assistant answer us with text, which is type text. Then we continue conversation, and after we finish with all details about the book, assistant called suggested book tool. So we have this type function call suggest book. This suggest book is, as you remember, here in book recommendation agent, we have suggest book tool. So agent wanted to call it. It also assign a call ID and arguments. Arguments with request, which contains general, writer, minimum year and maximum year. So the same as we have here. So we have for this tool, here is our tool. So like here is a request with parameters, general, writer, minimum year, maximum year. And after that, we can see a tool role with type function result, the same call ID as here, and result. Result is our two books. The same as we have here in book recommendation agent. Now, assistant answer us with the text. So previous two messages were internal ones and user was not see them. We answer with that we want to order first book, and assistant transfer control and actually workflow transfer control from book recommendation agent to book order agent. How it's working? As we can see here, we have function call with handoff to first. So it means that it hands off control from book recommendation agent to book order agent via internal tool call. Here we have also tool call ID and arguments. Reason for handoff: the user wants to order a book. So next message is a tool with function result with the same call ID as here, and result is transferred. So control is transferred to book order agent, and as we can see, the next message was from book order agent. But here we can see a little bit of mess, like it switched back to book recommendations and to order agent. Why it's happened? Because here in workflow runner, not runner, but in workflow builder, everything is started from recommendation book agent. So all time when we reset their workflow, it started from recommendation agent, but workflow sees that everything should be in control of book order, and book order continues execution. We will fix this in a bit, but actually this does not affect the application work, so everything working as expected. Like here we have control in book order agent, so it asks that it's a great choice and ask about details. Could you provide address, payment method? We provided it, and actually in the end book agent called an order book tool. This order book tool is this one. Let's go to book order agent. As we can see, we have this order book tool, and order tool is respond with order ID, which we received here in tool result here. So everything is working as expected. So let's try to fix this mess with control. How to fix that? First of all, we need to do the same in order book like we did here with this name. But name will be book order agent, and we need name here. Now let's go to workflow builder. And in this workflow builder, we just need to change this initial agent. How to do so? we want to expect here string last agent. Here we want to switch by this last agent. Switch if agent is book recommendation agent builder name. Then we need recommendation agent. If it's book order builder, then we need order agent, and otherwise unknown agent. And let's pass this agent here. So move this little bit down. Here we need to create new variable for last agent and use it here and here. And we will fix this control small issue, but sometimes it could also happen that we also have this control changing because this handoff feature is still experimental, but in future I think they will fix it. And that's it. Now we have a complete AI agent system, tool calling, multi-agent workflows, and persistent memory. This is very close to how real production AI system built today. So in the next video I will go even deeper, like maybe vector search, workflow as agents, A2A, and more. Maybe we will focus on validation and error handling and other interesting stuff. So make sure to subscribe if you don't want to miss it. Bye!